Basic trig equations. To solve the equations for this lesson, we'll be using the unit circle, so it will be good if you could have a printed out unit circle in front of you. The first one says solve, use the unit circle, and answer in radians. Now we did this type of problem in an earlier section because when you want to get the x by itself and you want to get rid of cosine, what gets rid of cosine is inverse cosine. And if you do it on the left side, you have to do it on the right. And so we did a lesson about inverse, but we were restricted. We could only use half of the circle. But now we're going to use the entire circle, and we're going to find all the places where the cosine, which is the first number in the parentheses, is positive square root of 2 over 2. That happens at pi over 4 and at 7 pi over 4. Tangent theta plus 1 equals 0. So let's subtract 1 from both sides, and we'll have tangent theta equals negative 1. And to get rid of tangent, we would use the inverse tangent. So now we're looking on the circle to find all of the places that tangent equals negative 1. And that happens at 3 pi over 4 and at 7 pi over 4. So that's the solution to the equation. Just as a side note, when you see 1 over the square root of 2 when you're solving these, and you try to find on the circle 1 over the square root of 2, you're not going to find it because this has been rationalized. If you multiply the top and bottom by square root of 2 to get rid of the square root in the bottom, then you would have square root of 2 on top, and then the 2 would come out and be on the bottom. So just know that when you see 1 over square root of 2, that's the same thing as square root of 2 over 2. Sine x minus 2 equals 0. So add 2 to both sides. Sine x equals 2. And we inverse to get rid of the sine. So we're looking for all the places on the circle where the sine, which is the second number in the parentheses, is 2. But you're not going to find that. If you can remember from our graphing, sine and cosine never go above positive 1. They never go below negative 1. So anything above positive 1 or below negative 1 is not going to exist. Then this equation has no solution. Secant theta equals 2. Well, we don't have secant on the circle, but secant is the cosine flipped over. So let's flip over secant and make it cosine. And if I flip over one side of the equation, I have to flip over the other. So the left side would be cosine, and then 2 flipped over is 1/2. Now I can solve inverse cosine both sides. And I'm looking for where on the circle the cosine is 1/2. And that happens at pi over 3 and at 5 pi over 3. Now this last one's a little different. It's a little more complicated. We've got a cosine squared. This is actually quadratic, and it needs to be factored. So to make it easier to work with, we'll temporarily replace cosine theta with just x's. So it would look like this: 2x squared minus 5x plus 2 equals 0. And then you can factor that, and that factors into x minus 2 times 2x minus 1. Now if you need help with factoring, you need to look up some videos or whatever about factoring. That's not part of this course. So now it's factored. I can put the cosine thetas back in where the x's are. Cosine theta minus 2 times 2 cosine theta minus 1 equals 0. So where I had x's, I put the cosine thetas back. Now we'll set each factor equal to 0. Cosine theta minus 2 equals 0. 2 cosine theta minus 1 equals 0. Add 2. And so this is just like the earlier problem. There's nowhere on the circle where the cosine is 2 because the range just runs from negative 1 to positive 1. So we don't have any solution on that side. On the right side, you would add 1 and divide by 2. So now we're looking on the circle where cosine is a half, and that happens at the angles of pi over 3 and 5 pi over 3.